when you're working on a car, not going through a drive cycle, put over 100+ miles on it, and you still have 4 incomplete codes, only one option. Get rid of the car, put it out of its misery. Got a Mazda Miata. I've been waiting to do this video for a long time because I have not had a car that would not pass drive cycle. No, it would not go through its drive cycle monitors. Yeah, that gun is safety, and so we're good. So point being, I wanna show you what's going on with this car. Like give you a brief synopsis of the history of what's going on with it, as far as why I get it, and just 5 minutes. I'm gonna spend 5 minutes on it. I think I got 4 minutes left. So let's see here. The car comes with me every year, just because the car's not been driven. It's one of 3 cars this person has, and every year we just do an oil change, which is kind of, I think it's pointless, but we still do an oil change, get it inspected, ship it off. No problems. But for some strange reason this year it's not trying to go through inspection. And let me just give you what's incomplete monitor readiness. Just load it up. So I can immediately clear the codes. It will go through this misfire, fuel monitoring system, comprehensive component monitoring, and oxygen sensor heater monitoring. What's incomplete is the catalyst monitor, evap, the oxygen sensor monitor, and of course the EGR. This car is a little bit modified. It does have an EGR block off, which will not pass. So we gotta go through the systems here. Certain cars, certain things are going to go through monitors in certain fashions. It's going to go in like numerical order in a way, to a degree. It's more sequential. So, but certain monitors requires feedback from other sensors to continue to go through its monitor, such as the issues with this car, the oxygen sensor. The oxygen sensor can't go through its sensor monitoring if it's heating. Let's see here. If its catalyst monitor is incorrect. I'm not sure the exact details on this particular car, but I can tell you for a fact that without certain feedback from certain sensors, it's not going to go through. I was considering cutting the car off, but really quick, so basically what's happening, this car is in a purgatory of drive cycles. It's not intelligent enough to throw a code, and it's not dumb enough to not recognize what's happening. So there's no codes present here. The car, again, is not smart enough to tell us like, hey, there's a problem with this sensor here. It's a 99 Mazda Miata. Now, after 20 miles of driving the car, I'm like, hey, this is a problem here, because normally I can drive 5 miles, go around the block, no problems, and then I would have my 2 incompletes. Take it in North Carolina, we could take where I am, 2 incompletes pre-2001 you can get away with. Anything after 2002 and 2002 I recall and above, you can only have 1 incomplete code. So we're pretty much good. But I will say this, one thing I've noticed with this particular car is the downstream sensor is falling off. Now again, this car is not that intelligent. Look at that. That's even better right there, because I've never seen that one. Never seen that voltage. Normally what happens, it will get stuck at a lean reading around 0.90 millivolts or 0.1 millivolts, and it will kind of fluctuate between 200 millivolts and 90 millivolts. So it would not perform like a normal oxygen sensor, and these are oxygen sensors that are on this car from the downstream. So this is one we're looking at, and it's stuck. But I'm gonna give you a little bit of input, because I need to make my videos just a little bit more educational. I'm not the smartest person in the world, but if there's anything, please put it in the comment section. Probably some feedback, because all the information is helpful, because I'm still learning. But a lot of people tend to get rid of their cars because they cannot go through a drive cycle and have to get waivers. But hopefully this video will give you a little bit of insight on what you can do to help ensure that your car is properly going through a drive cycle. Now, this car is unique because it has its own issues, but the same principles still would generally apply. So again, I've been waiting for a long time to do this, a while, but I'm going to try to keep it very basic, and hopefully we can jump right into the replacement to get this issue remedied. Let me cut this car off. All right, now I know a lot of people probably isn't gonna have like the fancy scan tools, or like understand PID data that's readily available. I mean, it's a learning process, and I'll be honest, I had a generic scanner for a long time, like that Syntec or some shit was sitting in his car. Let's see. I have this bullshit from Harbor Freight, and you know, I still use it. I mean, I don't. If I just need some preliminary data, I'm still going to use it. And what I'll do, I'm going to hook this up, because I know a lot of people just have generic scan tools. I'm going to show you what you can do, and I will look at the bigger one. And but it's still the same. It's just a little bit better laid out, displayed. So hopefully my camera will be able to pick up the small screen of this Syntec here. And I got this from Harbor Freight. The best investment for like a mechanic who's in tune with what's going on, because you need data. You need PID data. I can't even get to explain to you how important just the oxygen sensor information is if you're working on around the 2000 era vehicles, like post 2000, even pre, you know, OBD2. Anything below like 2010 or something below is going to help. Now, it's not great for oxygen aperture ratio sensor, because it's likely not capable of interpreting the aperture ratio sensor information. But you'll have like something, but you're not going to get good PID data because it's generic. So that's the only drawback. But for most vehicles that are older, you know, pre-2006 likely, you'll be fine. But this is that case. I'm going to hook this up in the car, and we're going to look at this generic PID data, and go from there. Alright, you're going to have to bear with me here, because I got the heat on. It's like 30 degrees out here. So what I normally do when I try to go through a drive cycle, of course, to get it connected, issue is it might not populate as far as the readiness. So like this car, I'm going to hit enter, go to diagnostic, and immediately it's going to start showing what's incomplete and what's complete, what's incomprehensible, or whatever the other revisions are. So we'll get that to load up for us. Just take a second. So yes, I'm going to erase that. So just look at it really quick. Monitor's incomplete, code's found, so we're still incomplete by 4. Monitor's okay at 4, and I guess it was incomprehensible. Let me see. Let's go back to readiness. I can still go there, but it's only going to show the monitor status. So again, it shows the same information from my generic version of my scan tool show, because that's where I was. All right. Now, really quick, if your car is not going through a drive cycle and you're stuck like I'm stuck, use your incomplete monitor readiness for information to point you in the right direction. Again, this car is not that intelligent. I don't even have check engine light codes. I can drive this 1,000 miles if I wanted to. It ain't gonna do shit. It's not gonna do anything. So, as a mechanic, you gotta figure this stuff out. So the little clues here are going to be what's incomplete. We looked at the incomplete data. It seemed as though it went through the basics that I mentioned above. It stopped at the heater monitor, which is okay. Now, for some strange reason, the EGR valve is not going through. The EGR valve is deleted. Sensor monitor is incomplete. EVAP system incomplete. catalyst monitor is incomplete. Now you have to take the information from past experience and just observing monitors over the years, but generally your oxygen sensors are going to go through monitors first after these misfire, fuel system monitor, and comprehensive components. These are just going to be immediate. You start the car up, bam, you're good. The catalyst, evap system, secondary air, oxygen sensors, EGR, those have to be driven. They have to be driven to go through its monitoring, because there has to be certain temperatures, there has to be certain speeds for them to be in a static condition, like just normal running condition, because these are integral for emissions. So just looking at the clues here, the evap has to be driven. The oxygen sensor started working, went through its phase here as far as monitoring, but stopped. And again, the oxygen sensors are generally going to go through its monitoring as far as first, I would say, after the initial comprehensive monitoring. So you start the car up, it goes through its basic testing. Then once you start driving, the evap can go through, but it may require the oxygen sensors, may not. But generally, if you're driving the car, it's not going through, look at your oxygen sensor information. Your oxygen sensor data is going to give you some information as far as if it's capable of going through. Again, this car is not that intelligent, so it's not going to tell me that there's a problem, because the computer system is just a 99. It's just not that fragile. Now, if it was a broken circuit, yeah, it could, but it's showing voltage, so probably based off the algorithm of the computer, it's not going to make a determination that there's a problem there. So I'm going to go to live data here, and I'm going to show you what the problem is with this car. Other thing is, you want to make sure that the car is in closed loop status. This is fuel system status 1. This has one bank, so it's closed. If it's OP, it's open, meaning that the temperature has not reached optimum temperatures yet. Make sure the car goes into closed loop. So basically, when you warm the car up, it warms up efficiently, it goes into closed loop, CL. 2 banks, it'll be closed loop, and the average temperature for most cars are 180 degrees. Alright, so if you drive the car and the temperature start to drop, this needs to stay steady at 180. It needs to stay in closed loop, because the engine coolant, ETCs, the engine coolant temperature, this is monitoring the loop status. Once it hits a certain temperature threshold, it's going to close it off, and things are going to start running more optimal, because everything is in a more consistent environment for that manufacturer. So we got fuel system status, low percentage is irrelevant right now. Short term, long term is irrelevant right now. You got vehicle speed sensor, spark advance, intake air temperature sensor. Now this is important also. If your intake air temperature sensor isn't within specifications, which generally has to coincide with the engine coolant temperature. So the intake air temperature sensor and the coolant temperature sensor generally have to be within 20 degrees of each other and below 90 degrees typically. So if your engine coolant temperature is below 90 degrees in most cases, and within 20 degrees of one another, you're fine. The open loop should work out pretty well for you. And that's usually vital. Those two are usually vital for evap. So when the intake air temperature sensor and the coolant temperature sensor are below 90 degrees and within 20 degrees of each other, typically the evap system is generally going to be ready to go through its testing. Now, if you're a mechanic and you're driving around, my little trick to do this on some vehicles, it works. You can either take your scan tool. This worked on a Hyundai before. Take your scan tool and go through a evap test, like a purge, like a seal test. Once it goes through its seal test, it will, in rare cases, force the computer to recognize if there's any large or small leaks. That's one method. The other method, too, if you're having a hard time going through your drive cycle and it's on a hot day, pour water on the engine. Get the intake temperature sensor below 90 degrees. Get the coolant temperature sensor below 90 degrees. And turn the ignition switch on. Start the car up. The car is going to think it's been sitting for a while, and then drive it. So that is a trick that I utilize. Some cases it works, some cases it don't. So just put that in your arsenal. Pour water on the engine, get it cool. If you're like in a desert somewhere and it's 100 degrees, it has to sit overnight for the car to get below 90 degrees typically. So pour water on the intake air temperature sensor and the coolant temperature sensor. Get them both below 90 degrees. Usually if you let the waters flow through there, it'll pull that, it'll lessen the temperature. So that's one other method. So that's the evap. So with this car here, since I'm going down, you have to make sure, of course, your vehicle speed sensor is operative. If your vehicle speed is inoperative, your car is not going to know how fast it's going. These are important PIDs, because it needs to know if it's within range, because typically a car needs to go 55 miles per hour for a drive cycle, and it has to maintain that. These cars have like some of these cars have internal clocks, so it's going to clock you after you start going a particular speed. I don't know if you ever look down at the PID data. Once you start running, it's starting to count. You know, so sometimes you can't outsmart these vehicles, but the older the car is, the better odds you have. Alright, so you need coolant, intake air temperature, vehicle speed. Of course, you know, all the other sensors need to be operating. And I'm just assuming that, like this car, it has no check engine light. Take care of your check engine lights first. But this car has no check engine light. This car is not going through a drive cycle because, again, it's stupid. It's dumb. It's just not that bright. But I'm not going to let this outsmart me, because our voltage for our downstream O2 sensor for the catalyst monitor isn't within range. It needs to be ideal, which is around like 0.45 millivolts. So 450 millivolts. It needs to generally be in that standing, and it sort of needs to oscillate typically around 70% less than the upstream. Let me show you what oscillation is. It'll work. Okay, so this is oscillation. It's generating a frequency. And what happens, if this is 1 volt, 0 volts, even though we got a graph here on I think it's a y-axis, I think. So this has a frequency. The downstream needs to oscillate 70% less than this. So what you'll see is a flat line. It'll look more flat, straight more so, but it'll still move. It'll just not be of this type of oscillation that you see here. So you want it to flatline basically while you are driving. Idling conditions are bullshit. So you need to drive the car 55 miles per hour to 60, whatever the speed limit is for that vehicle, but typically it's 55 to 60, and cruise there under normal load conditions. So you're not accelerating hard, you're just cruising along. It starts to stabilize, and your downstream sensor will just flatline. Alright, this video is going to be a lot longer than I thought, but I think this is very helpful though. So I'm gonna go ahead and we're gonna go ahead and resolve this, and I'm gonna take the road less traveled. I'm going to put a universal oxygen sensor on here and repair this. I know a lot of people are talking about it, but the thing is, it's the same oxygen sensor as any other ones. It's just a plug. You're paying for a plug. It's crazy. You know, you can save $100 in some cases just from knowing how to wire a universal oxygen sensor. But we got information here. We see how it's working. We're going to compare the information because now it's stuck. I can go through a little bit more testing with this sensor by pulling the voltage down, by grounding myself. So grabbing the signal wire and grounding myself to the battery. So I'll put one hand on the signal wire and one hand on the ground side of the chassis or the battery. This number should drop. All right, I'm at 21 minutes now. I know I've been rambling. I'll consider it. Another thing you'll want to check for if you have downstream problems is for exhaust leaks. This does have one. However, it will cause a lean condition. Nothing of the rich conditions that we are observing. So I'm going to ignore this. And again, the computer's not that intelligent. It just needs to see stability. My oxygen sensor's here. So I'm gonna have to go under the seat. That's right, because I had another I did a while ago. I have to go under the seat, access the connector. So I'll pull the seat forward and get to the connector. Let me do that. So we're behind the seat here. Another thing you want to inspect, of course, when we do a visual inspection, is around the area here. So where the connectors are. This has water accumulated. I'm gonna pull this connector off and see what it looks like, because the possibility it just may be a poor connection or water damage. Let me get this together. So one thing I want to make sure that the water wasn't contributing to the problem here. I did inspect the connector. It was perfectly fine on the inside. No corrosion or anything. So let me show you one thing. Oh shit. So the voltage was really high. Voltage was high on the downstream here. Now, to eliminate the possibility of it being like an electrical issue, disconnect the sensor. I'm going to disconnect this sensor here and see if the voltage changed for the downstream. So bank 1, sensor 2. And this will help you determine if you're at the right sensor also. What was something else I noticed? So OL, open loop fault. That's just the indication that there's some discrepancies or some issues with the oxygen sensor. So, which is a good sign, but there's still no check engine light. This is why when you have a faulty sensor, luckily the upstream is still working properly. It's reading a little lean right now, but sometimes the downstream can impact the upstream operation or the overall fuel trim because of depending on how the computer system is operated. So be mindful of that, but that's another video. So I'm going to disconnect the sensor, and we're going to note if the upstream changes also at the same time. See if that voltage changed, so at least we'll know if there's some type of electrical issue. So we'll know if there's some electrical problem present. So let's disconnect it. Alright, so that dropped to 0, which is cool. Sometimes the cars might be running a little lean because of the way it's positioned. I mean, I do got it jacked up and the fuel pump isn't sitting properly, but that's not our primary focus. Now we know that there's no electrical short in the system because there's no voltage still present in the L2 sensor. So now the only other thing is going to be is just a faulty sensor. I'm going to pull that out, go get our universal one, and we're going to wire that up. The universal O2 sensor here, direct fit. You can see the sensor here doesn't look that good, and honestly a person could try cleaning it. I'm not going to do it because I mean as the age progresses, this just doesn't seem like a healthy sensor. But I'm going to get this installed. It's very simple instructions. How do you read this? You just match the corresponding wires, and this is generic, but it'll give you an idea. So on the factory one, we have 2 black wires, a blue and a white wire. You don't just look at it and match it to the, so you just don't find the white here and match it to the gray, and then you'll find the blue and match it to the black. Just look for the, just narrow it down. We got 2 black here. We're going to look in the middle for the heating circuit, 2 black. The 2 matching wires are generally always going to be the heating circuit. So we got blacks right here. Now we just need to find the white and the blue. It's not blue. It just doesn't look really blue around here, but this is the closest blue we got. This is the white. So this is where I'm going here. So I'm going to match the 2 blacks with the 2 whites on the universal. So this will be the direct. This will be the phone call coming in. Hold on. Had a phone call come in. Alright, so I got mine's buttoned up. I soldered mine's together. Forgot to put the insulator on here, but I'll go back over it. But just really quick, the 2 matching wires are going to have the 2 same matching on the heating circuit. So black and black on the direct fit, white and white on the universal. Those 2 are matched. Blue and black. Blue on black right here, and white on gray, white on gray. I do have these 2 buttoned together, but they're both individually insulated with wire tape, and then the heat shrink is holding them 2 together, so nothing's going to happen. It should be perfectly fine. But I'm going to get this button back up. We're going to look at the pit data and ensure that everything's working fine, and complete our drive cycle. So one more thing I want to add before I do my drive cycle and update. When you start the car up, sometimes, well, generally it's best to let the car idle and warm up on its own to normal operating temperatures. Reasons being, some instances the evap can go through its testing phase. Some instances, so it's recommended you let it start up and run for a few minutes and then drive it. I think, don't hold me on this, but I do think someone require you to start up and drive while in open loop and let it go into closed loop. Don't hold me on that. Don't hold me on that. I need to get a little bit more information. But it's best just to let it start up, let it idle, and do not, and I mean do not cut the car off. So don't let it warm up from a open loop status, closed loop, shut the car down and cut it back on, because you're gonna have to wait for it to cool down again before you can start up and the car recognize it being an open loop and it going through its driving monitors for like the evap, for example. So it's best, again, just reiterate, it's best just to, from a closed loop state, start up, let it idle to warm to normal operating temperatures, then drive it and hit the highway for about 10 minutes, come to a standstill for about 5 minutes. That's a little excessive, but generally for about 2 minutes, then progress in speed again for another 10 minutes, go the opposite direction, come to an idle, and just let it sit for a little bit. And normally it'll go through a grand majority of drive cycle monitors, so you don't have to drive the car 50 miles. It's just in a closed loop state, generally you'll hit majority of those incomplete monitors driving 50 miles, but you don't have to. I mean, you can complete a grand majority in like 20 minutes and well under 20 miles if you know what you're doing. So, but we don't have any stuck voltage here. One thing I can do, I can add some fuel in here to see if the downstream reflects, because before it was just getting stuck, but I didn't capture that because it was already stuck really high in a rich condition. It's kind of pointless to do any type of rich mixture and see if it reflects on the downstream. But let's see what our temperatures are since I've been run off at the mouth. 114, so it's in closed loop now. I'm going to go ahead and take it on my test drive, monitor my monitor my downstream, and see where it goes from there. Now that exhaust leak I didn't repair technically needs to be taken care of, because right now this looks like a reflection of an exhaust leak because it's lean. But once like I said, I'm kind of going off the cars not being intelligent. When I drive it, the flow should not be disturbed to the point where it'll become steady, and it'll get a decent reading. It's not that bad, but it still needs to be replaced. But if anything happened, I'll update. The car passed inspection and everything went through pretty smooth. I just want to show you, without showing you all types of crazy information, that it has passed. That is a Miata. Got today's date. It'll focus. So everything's fine. I just want to show you that the car is stupid. I'm just gonna straight up put it out that way. Why did I do that again? Hold on. Sorry, I don't know why I have a bad habit of pushing that button all the time. It just got it out for me. So the car is not that intelligent, and let me just show you the vehicle status. So there's 2 incomplete codes. So the evap didn't go through, or the catalyst and monitor, which in my location you can have 2 incompletes. So it passed fine with flying colors with the handicap. Catalyst monitor is incomplete, but the EGR valve has passed. The EGR valve on this car is deleted and disconnected. So that lets you know how intelligence with older cars can greatly vary with what's current. So the catalyst monitor is not done, and the evap, not a big deal because this car passed. What do I want to add? The flatlining you saw earlier or previously after I put in a new sensor, I did replace the exhaust leak, so that's fixed. I wasn't completely satisfied because I don't have the information on the oscillation of the downstream or post-cat sensor. So I did put an extension in there because I was thinking that the catalyst is inefficient, but this car's emission system is inefficient. So evidently it just doesn't seem to care if it oscillates as much as the upstream sensor. Crazy. Now it flatlined for a while in the previous video, previous clip, because the sensor has not yet heated up. I mean, it's pretty far. Again, this has a big exhaust. It takes a while for the exhaust to heat up, for the oxygen sensor to generate a signal and produce a voltage. So that's why it flatlined. But now everything oscillates, it moves, the heating circuit's appropriate, it went through its phase, its monitoring phase, so everything worked out. I don't know if I add anything. I want to say, just to recap, don't drive the car I want to say, just to recap, do not start the car up from a cold state, shut the car off after 5 minutes of running and expect the car to go through a drive cycle. It's just not going to happen, especially with a newer car. And a lot of these cars are timed now. If you look, if you look down at the bottom of some of the PIDs, you'll see a clock. Like they're being timed. So it's getting more and more difficult to outsmart these cars nowadays. So you gotta be very mindful of that. But don't be overwhelmed, and if your car is not going through a drive cycle, because like this car did, I'm just glad this happened, so I could just provide some insight on it. I mean, there's really not too many videos out there as far as going through drive cycles. But don't change the computer. Look into your sensors and see if there's any discrepancies, like with the oxygen sensor on this car, because like I call it, it may be sitting in purgatory. So it might just be in that fine line to where it's not smart enough to detect the problem. The computer might not be smart enough to detect the problem, or it might not be dumb enough to really have a great influence on reacting with the computer to go through its monitor. So could be a few things, but check the status of that sensor and make sure, or the ones that aren't going through his monitor, and see if there's any type of issues. But don't get discouraged. I'm not the smartest guy in the world. I can assure you that I am not that intelligent. Look at some of my past videos. I make mistakes just like everyone else. But hey, this world is full of infinite possibilities, man. Anything can happen. This car could come back. But I don't see why I only see this once annually. You get the idea. Hit the link. Subscribe to the channel. Stay informed. Have that reassurance in my work. And so on to the next one.